Hello students, and welcome to the second video of part 2.3 of module 2. And in this video we're going to start to look at how to actually use that power rule that we learned in the previous video and how to actually apply it in many different looking cases. Let's get started. So here we're going to be practicing derivatives, and what you want is that any equation that you get to be written in polynomial form. So what is polynomial form? And so you're going to want to write this down. A function in polynomial form is the sum or difference of multiple monomial terms. So what is something that could look like? Well, you could have something that says f of x equals a times x to the n, and then you could have plus b times x to the n minus 1, so some other exponent there, plus c times x to the n minus 2, and this could keep going on forever, so plus some whatever the next term is all the way at the end to a constant. So anything written in this form, we can apply the power rule to. So in some cases, we need to write things into that form, and you're going to see how rewriting equations is going to be super important to using the power rule effectively throughout calculus. So we want to find the derivative here, but we also want to leave our answers without negative or rational exponents. And we want to leave it as single rational functions, so we don't want to have two separate fractions there. So what I'm going to do here in our first one is I'm going to rewrite f of x. I'm going to say, all right, so f of x equals 2 times x to the negative second minus 4x cubed. All right, and now I'm going to apply the power rule. So f prime, now I'm taking that derivative, equals negative 4x to the negative third, so multiply and then subtract 1. So then minus, and then multiply 4 times 3 is 12. X, 3 minus 1 is 2. All right, so now I want to do some extra work here because I don't want to leave it with negative exponents, okay? So no rational exponents either, so no like 1/2. We also want to move everything into one fraction if possible. So I'm going to keep f prime of x going, and this is going to be negative 4 over x cubed. So now it's a positive exponent, minus 12x squared. But what I also want to do is combine these into one fraction. And so I'm going to multiply my second term times x cubed on x cubed, just like that. And I'm going to get negative 4 minus 12. Well, x squared times x cubed is x to the 5th all over x cubed. So that's going to be my final result in this case when everything gets written as one fraction. All right, so now let's look at our second problem. Well, what I notice here is I can rewrite f of x, and all I do is divide each of those terms by x. So 3x to the 4th divided by x, I get 3x cubed. And then 3x squared divided by x, I get minus 3x. And negative 2x over x, I get negative 2. Now let's apply the power rule. So f prime of x equals 9x squared, multiply and subtract 1, minus 3. And then that constant at the end with the 2 is 0, so minus 0. And so this is going to be my derivative for that pretty nasty function at the beginning. But you see, just 2 steps later, using the power rule, we got something very quickly. All right, now on to our third problem. I'm definitely going to want to multiply all of this out to make it into polynomial form. And so I'm going to get f of x equals, let's see, x squared plus 5x plus 6, and I still need to multiply all that by 2x plus 1. So then let's keep going here. I'm going to get x squared, so I'm going to get 2x cubed plus x squared plus 10x squared plus 5x plus 12x plus 6. All right, so I'm going to combine all of my terms here. So f of x equals 2x cubed plus 11x squared plus 17x plus 6. That looks right. And now I'm going to apply the power rule here. So f prime of x equals 6x squared plus 22x plus 17. For all those, multiply by the exponent and subtract 1 from the exponent. And that right there is going to be my final derivative. Now let's move over to our fourth problem. And what I'm going to do is something similar in problem 2, where I rewrite this by subtracting the denominator from the numerator. So I'm going to have x cubed minus x to the fifth, or divided by x to the fifth, so 3 minus 5. I'm going to get x to the negative second minus 5x to the negative third. All right, so now I'm going to take that derivative, so f prime of x, using my power rule, so bring it down, multiply and subtract 1, plus 15x to the negative fourth. All right, so now I'm going to rewrite this with rational exponents. So negative 2 over x to the positive third plus 15 over x to the positive fourth. And so I have two fractions here, and I want to write them as one fraction. So my first one, if I can make that x to the fourth, then I'll have a common denominator. So I'll multiply it by x over x. And so my next result would be negative 2 times x, so negative 2x plus 15. I didn't multiply my second fraction by anything. All over x to the fourth. And there, now it's all going to work out. All right, so now I want to do our fifth problem here, where we have some radicals. They're in the denominator. So let me rewrite this real quick. So f of x equals 3x on x to the 2/3. So just rewriting that radical with a rational exponent. And then I'm going to subtract. So I have x to the first minus x to the 2/3. So I'm going to get f of x equals, let's see, what's 1 minus 2/3? That's going to be 3x to the 1/3. And then now I can take that derivative. So f prime of x equals 3 times 1/3. That's going to get me 1. Okay, so x, and then 1/3 minus 1. So subtract 1 from the exponent. That's going to get me negative 2/3. All right, so I need to rewrite this a little bit. So f prime of x is going to be 1 over x to the 2/3. And I still need to write that without a rational exponent. I want to write that in radical form. So that's going to be 1 over the cube root of x squared. And that's going to be my derivative in the end. Now I've got one more problem here in this video, our final one. And it looks like it's already in polynomial form. So let's just bring down the exponents, multiply, and subtract 1. So f prime of x equals negative 3x, and then 3/4 minus 1, that's going to get me negative 1/4. And then 1/4 times 2, that's 1/2 x. And let's see, 1/4 minus 1, that's going to be negative 3/4. All right, so I've got that down, but I want to rewrite all of these to be very, very clear. So that's going to be f prime of x equals negative 3 over x to the 1/4 plus 1 over 2x to the 3/4. All right, so what I have in my denominator on the right side is I have x to the 3/4. And on my left side, I have x to the 1/4. So if I multiply here, if I multiply that first fraction by x to the 2/4, and I add those fractions, so 1/4 plus 2/4, I will get 3/4. So I just need to make sure that I multiply my numerator by the same thing. Well, 2/4 is 1/2. So let's see what happens here. So f prime of x equals negative 3x to the 1/2 plus 1 all over, well, oh, I forgot to multiply something. So that only takes care of the x part, but I have this 2 over here that I need to multiply by as well. So I'm also going to multiply my first fraction by 2 over 2 as well, just to keep that common denominator. So now I'm going to have, I need to fix my numerator now. So that's not going to be -3. I'm going to have -3 times 2, which is -6. X to the 1/2 plus 1. And now in my denominator, I'm going to have 2x to the 3/4. All right, so let's write everything with the proper radicals. So we're going to get f prime of x equals -6 times the square root of x. So remember, 1/2 just means square root, plus 1 all over 2 times the 4th root of x cubed. And that is going to be our final derivative for that 6th problem. So taking the derivative using the power rule, that wasn't an issue. That happened in that first step up there, and that was really, really simple. But doing all that rewriting over there on the right side, like the additional 3 steps, I know that is really going to stretch y'all's algebraic reasoning. So stay with it, really work on those algebra skills, and really remember why you're doing everything in each of these steps. All right, everybody, thank you for joining me today. We have, I think we have 2 more videos in this where we're still gonna go over more practice finding tangent lines. We're still gonna find derivatives of trigonometric functions. So stay with it. We have 2 more videos left. If you do need any help on this lesson, reach out to me. I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.